So yeah, welcome everyone. And first of all, I'm very happy to be here, and I would like to thank all the organizers of this conference to putting this all together. So today I am going to talk about integrations in Keptn. So we will discuss how we can integrate K6, which is a performance testing tool in Keptn, and how we can validate the SLOs in Keptn's quality gates. So yeah, a brief introduction about me. I am Jainam. Currently I am working as a software developer at JioSaavn. So last year when I started looking into the cloud native tools and SRE practices, I came across Keptn. So I built the integration of K6 for performance testing in Keptn as part of a Google Summer of Code. And I love participating in hackathons. Apart from that, I like traveling a lot, and in the evening I just like to shut down my laptop and go outside in the open sky to play games. So yeah, now let's talk about Keptn. Keptn is a CNCF incubator project. It's open source right now, so it is designed to streamline the continuous delivery and automate the operations for cloud native tools. As complex pipelines are hard to maintain, Keptn provides a framework for automated deployment and management of our applications. It integrates with tools like CI/CD. It integrates with CI/CD tools and monitoring system for end-to-end deployment, testing, and managing the application in cloud native environment. So yeah, the following are the features of Keptn. So it follows GitOps principles. So all the configurations and the deployment information will be stored in a version control. So each and every project of Keptn will have a Git link associated with him, Git repository associated with him. Keptn leverages cloud events for triggering actions based on events. So this allows us to have integrations with tools. Keptn has flexible deployment pipelines. So we can declare pipelines like dev, staging, and environment. So Keptn's quality gates, they help us to validate the SLOs. So SLOs or service level objectives are a specific set of targets which are defined for a service to provide. So an example could be that an SLO is that the response time of a particular API should be less than 100 milliseconds. And SLI, so service level indicators, they are basically the matrix that tells us about the performance of the system. For example, SLI would be that the P95 of a particular API is 95 milliseconds. So Keptn allows us to automatically validate these SLOs. So it also allows us to monitor our systems. So Bridge is a dashboard of Keptn that is a dashboard for looking at all the projects and services, and also it gives us it helps us to monitor and give insights about the behavior and performance of the application. Keptn has recently introduced Keptn Lifecycle Toolkit. So this is a completely cloud native tool which extends the Kubernetes APIs, while Keptn is mainly operates on the events triggers. So this basically allows teams to manage their whole software lifecycle cloud natively. It provides a bunch of features like pre and post deployment checks, and also we can continuously monitor the application health checks. In this talk, we will mainly be focusing on the Keptn integrations via cloud events, but there is a very beautiful talk given in KubeCon this year. It's navigating through delivery life cycles with Keptn, which focuses on Keptn Lifecycle Toolkit. So Keptn basically allows us to define the multi-stage delivery of the workflow of our project. That is basically done via Shipyard File. Something wrong with the presentation. Yeah, so shipyard file in the Keptn allows us to do that. Let's take a look at the at a shipyard file. So this is how a shipyard file looks. So it will define it is defined at a project level, and all the microservice of that project will go through this will directly go through this whole sequences of stages that are defined over here. So stages, as the name suggests, it's the different stages of an application that it's a different stages of an application. So it could be like dev, staging, and environment or production environment. So there will be different Git branch in the Keptn project corresponding having files of each and every stages, and also all the microservices will be deployed to another namespace of the Kubernetes based on the staging. And each and every stages have a particular list of tasks that are called that are defined in the sequences. So sequences are all the list of tasks that will be executed in that stage. So for this instance, I have added a test and evaluation task for production stage. So if the test stage is passed, then only it will move to the next step, that is evaluation. For this talk, the test stage will be referring to the performance testing in the Keptn, and evaluation will be the quality gate evaluation or SLO validations in Keptn. Now let's talk about K6. So first of all, performance testing gives us about the speed, responsiveness, and stability of our system. So it helps us to for better user experience, and also beforehand we can decide on how on the performance testing we can decide the scalability and capacity of the system. It is important for software lifecycle and because it identifies and fixes the performance issues in the early stage of the development cycle. So what is K6? K6 is an open source tool for load testing. It has an enterprise solution too for it, but there is an open source tool also available for it, and it is widely accepted around across cloud native tools. So K6 has very good resource utilization, and even one load simulator can generate tens of thousands of virtual users. So virtual users, we can say like it's a while true loop which will continuously keep on testing on the API that we want. And K6 is code driven, so it uses JavaScript as a scripting language. Also K6 allows us as a part of extensions that we can write the test matrix into Prometheus and other data tools too. So this is how a general K6 script looks like. Over here we have defined that there are 50 virtual users and the duration will be 3 seconds, and we will hit this API test.k6.io. And this is how the output of K6 run looks like. It will provide us with all the metrics that we want, like HTTP request duration and error rate and all. K6 threshold. So K6 thresholds is a feature that allows us to codify the SLOs in the test. So this is basically a pass-fail criteria only. For example, we can specify that the 95 percentile of the request should be the response time should be less than 200 milliseconds, or the error returns should be less than 1%. So this is how a K6 threshold can be defined, and over here we have added that HTTP error should be less than 1% and all. This is a pure pass-fail check. So if each and every thresholds have been passed, then it will exit with a 0 exit code. Otherwise, there will be a non-zero exit code for K6 script. K6 extension allows us to expand the use case of K6. So we can build custom binaries to, let's say, write test matrix into data sources like Prometheus or Dynatrace. So K6 is the command line tool that allows us to do that. Now let's talk about K6 integrations with Keptn. So let's go through the Keptn-K6 workflow. Things might be a little unclear right now, but we will go into detail of each and every step right now. So first of all, we will declare the shipyard file. The shipyard file that defines all the stages and everything. And over there in the test task, we will define a task for a stage that we want. Then we will set up a job executor service. So job executor service allows us to run any workflow that we want in Keptn. So for this tutorial, for this instance, it will be subscribe to test.triggered event and start the K6 execution, K6 load testing, and then we will create a service. So service is basically a microservice that we want to test. So this is how a general K6 general Keptn integration looks like. So we get a triggered event, it is sent, and whichever service is subscribed to that event will receive it and send a started event back as an acknowledge to the Keptn control plane. Keptn control plane is an orchestrator which sits in the middle and manages all the events and everything. And then once a service has sent the started event to Keptn control plane, it might fetch some files from the Keptn and executes. In this case, it might be a test execute a script, a K6 JavaScript which executes the test. And once it's finished, it will send finished event back to the control plane, and then control plane will move to the next task of the sequence. So job executor service is a single service which allows us to execute any task as a short-lived Kubernetes jobs in Keptn. So this helps us to easily integrate with testing, health check, deployment, and remediation. Just a few lines of YAML config will create it. So let's take a look at a job executor service config. So this is how a job executor service looks like, configuration looks like. It provides, it mentions the event which it subscribes to, and at the end it uses a K6 Docker image which will be used to run the command mentioned at the below. So we will run this K6 run command and mention all the files and arguments that we want to pass. So Keptn quality gates, they are validation validation that all the criteria are met before we are promoting the code to production. So let's take a look at the quality gates flow. So this is how the flow looks like. So first, the trigger evaluation is called by Keptn, and it internally there are two events inside this evaluation task. First, we fetch the SLIs. So from Prometheus, there might be any we will for example, let's say from Prometheus we want to fetch some matrix, and based on top of that, the SLOs that we have defined, we will evaluate them and get a score corresponding to that. So this is how a SLI config looks like for quality gates. It's just a Prometheus query. Yeah, and this is how the SLO config looks like. Over here we have passed the criteria for passing. So we have passed that P95 request duration should be less than 1 second. And over here we can add several SLOs, and based on that we can also assign weights to them and define that what score should be passing. So let's say we have defined 10 SLOs with each weight 1, and 8 are passing and 2 are not passing. So it will be, the score will be 80% overall. So unlike K6 thresholds, it's not binary over here. So yeah, this is how the K6 quality gates whole workflow looks like. We will also add a evaluation task in the shipyard, and over here we will use the K6 extension of Prometheus as a Docker image which will write the test matrix to the Prometheus, and after that we will get the SLI using the Lighthouse service of Keptn, and then the quality gate evaluation will happen. So yeah, let's take a look at the demo. So over here in the services, we have defined a microservice A, which will go through all the sequences of production stage, that is currently test and evaluation. And over here in this GitHub upstream repository, we can mention the repository where the whole Keptn project files and all that will be stored. And in the integrations, this job executor service is currently subscribed to test.triggered event. So let's just take a look at the output of how it looks like. So corresponding to this production stage, we have two sequences. One is test and another is evaluation. And evaluation internally calls the get SLI event. So if we take a look at the test logs, then first the job executor service is started, and then it finished with a result pass. If the job executor service returns an non-zero exit code, then it will fail at this instance only, and it won't go to the evaluation stage. And over here we can see the K6 logs, and also the thresholds that we passed in the script, they both are passing with HTTP request duration, P95 as 378 milliseconds. And if we take a look at the get SLI part, then it will fetch the P95 request duration as 398 from Prometheus. And over here we can simply see that the SLO validation has been done correctly, and we can also do the monitoring over here over the past sequences that has been done. So yeah, this allows us to do that. So to summarize all this, Keptn allows us to declaratively add the multi-stage pipeline, and using the job executor service, we can easily run K6 or any tool that we want. We just need a Docker image for that. And K6 thresholds can also be used in that step for SLO validation. And after that, once we have the performance testing, we can add the quality gates for checking if the SLOs are met. And for basically Keptn's quality gates allow us to not just have a binary SLO validation, we can have assigned scores to each and every objectives and then evaluate based on that. So yeah, thank you very much. And you can also find the tutorial for this whole talk in that link provided.